Oh, well, hello. How's it going? We're just vibing here a second while we get everything booted up here. Ooh, mute that. There we go. Lower the quality of that. Come back out here, pull up the stream so I can see chat, which I currently don't see right now. Gary, the good boy. Why am I not streaming on YouTube right now? Wait, what? Hello? There we go. Okay, now I see myself. Okay, that took a second. I don't know why I didn't see it. Boom, boom, boom. Lower the volume just a little because it looks a little bit too spiky. To Bread, hello. How's it going? Welcome, welcome. Chat, what are you doing at the bottom? Get up there. You guys know your place. Okay, so that's done. Move that over there. Okay, we're almost set up. And then move that over here. Minimize. And is that good? Hold on. Let me do a little bit of multitasking here. I think that's good. And we minimize. All right. We are ready. Okay, so today, our goal is to not refactor, but basically replace the current rectangles we have. So let's boot up the project here. You'll see the problem we have here, which is SDL rectangle. SDL rectangle, we're kind of hitting its limitations as a inbuilt thing. The problem is SDL rect is an issue. So right now when we render these shots, notice how they're not uniform, even though our formula should be. And the answer is SDL rect. It's taking what was previously floats, like velocity floats, and we're applying it to the rectangles to get them to move to different places, and there's issues. So basically today, what we're gonna be doing is we're gonna learn from a source. Rotating rectangles, C++ military. So conveniently, the Army Research Lab actually came up with this problem already. Creating, positioning, and rotating rectangles using C++, and it also talks about intersecting rectangles. So that's pretty sweet. So we're gonna learn from this today, and apparently we are to destroy this report when it is no longer needed. Do not return it to the originator. So that's gonna be fun. And look, I just found this at work. It's just a random PDF on the internet, and it goes over like every problem we could have about rotating rectangles, and it's pretty short too. So I don't know, it's gonna be pretty neat. Sine and cosine input are in radians, not degrees. Okay. So here's the thing. Before we start, I also looked up trigonometry. It was a slow day today. I also looked up trigonometry. So here's what I learned about trig today, okay? This is what I learned, and we're gonna apply it. So hold on, let me switch views here. A little bit too... There we go, now we're cooking. Okay, so this is what we learned about trigonometry today, okay? We learned the following. When you have a triangle, that's a right triangle in this case, and then we have this angle here. This angle, if we call it theta, imagine that's theta, not like an Easter egg shell or something. So we have theta. Well, this is the hypotenuse, this is the opposite, and this is the adjacent. Now, if we want to find like tangent theta, we make it equal to SOHCAHTOA. So so it's O divided by A. And then same with sine theta is going to be equal to opposite and hypotenuse, which is opposite divided by hypotenuse, I think. And then cosine theta, which is equal to adjacent divided by hypotenuse. And there we go. Now we have SOHCAHTOA. Hey! So that's kind of the logic here. Now, the 100 or the pi divided by 180, the reason why we did this is because this is a conversion to radians. So apparently we're going to talk about that in a second in the program to see what we did. But when we multiplied by this, that converted it to radians when we had our rotations and all that. So that's what I learned about trigonometry today, okay? It's pretty easy, it's self-explanatory, but now we have any way we want to find what theta is, and that's gonna judge the angle we shoot our bullets at. There we go. I spent 3 hours studying this shit today for you people, all right? Did I get trigonometry down? Are we happy? Do I need to ask you people for formulas anymore? Okay. Also, if you're asking me what like a tan is for like inverse tangent, I think the only difference is instead of this angle here, it's like the opposite. It's like this. Or not this, sorry. This. So if I need to, fuck, I still drew it wrong. God damn it. If I need to draw, no, wait, fuck. It's right angles over here. Boom, boom. There we go. Okay, so if I need to find this theta, I need to be careful because in order to find that theta, I need to do opposite and adjacent. But I think this is inverse tangent, right? Because you were going on the opposite side of the 180-degree line. I think that's the logic there. Wait, this stuff is useful? Yeah, we're gonna do it today, actually. We are actually, hold on, let me get a better view here. So we're actually gonna apply this today. The Army has already solved this. We're gonna follow this, by the way. They go over rotation, intersecting, all that shit. But if you look, where is it? There's formulas. Hold on. They have a double array, 2D array. There's one specific formula for outputting. Oh, they recreated this, by the way. They basically created rectangles and then have a certain distance between rectangles. So now they also gave us like a formula to randomize rectangles on the screen. I thought that was pretty fucking cool. And then they give us like a source. Hold on, where's our formula here? That's a for loop. Oh, I don't see it. But anyway, we're gonna come back to that in a second. Now, let's talk about what we're doing. This coming weekend is Mardi Gras. Wow, I'm gonna be inside programming. Have fun. So angle is equal to the inverse tangent of velocity x, 0 minus velocity y, times, this is incorrect, right? Because it's not 180 divided by pi, correct? It's pi divided by 180. That is how you convert to radians. I think that is correct, right? Because in a circle, I could look this up online, but let's draw it. Because in a circle, ooh, hold on, I'll give you guys a clean circle. Boom, look at that, beautiful. Because in our circle, right, if this is 0 and this, excuse me, and pi, because you do one full rotation, this is pi divided by 2. This is pi divided by 4. This is pi divided by wait. Hold on, I'm doing this wrong. Is it 2 pi is a full rotation? No. Pi is 3.14, which is the amount of times the diameter takes to go around the circle. So this is pi. This is pi divided by 4. This is pi divided by 2. What's 3/4? Pi divided by 0.5? No. That makes it 2 pi. Wait, what the fuck? What is this one? Oh, wait, is it 3 pi divided by 4? Is that what it is? Uh-oh. Oh, it is 3 pi divided by 4. Okay, sweet. Wow. Whew. Anyway, now here's the thing. If we're gonna convert into this from a degree, why are we doing 180 divided by pi? That doesn't make sense to me. If we are converting to radians, we need pi divided by 180. That is correct, right? So this is incorrect. I think this has to be m pi divided by 180. So let's try running it. That didn't look right. Okay, hold on. Never mind. I was wrong. I was wrong. Oh no. Wait, it is 180 divided by pi? I was proud of that. Fuck. What are you doing? The wrong thing. Anyway, I thought I was cute figuring that out. Oh, actually. No, that should stay. Basically, we're understanding trigonometry. Okay, this is fine. Everything is fine, but we're gonna recreate SDL rect and replace all SDL rects in the program with the new function. That's what we're gonna do right now. I think this is gonna go under initialization, right? Oh, but everywhere is gonna take this. Ooh, I don't wanna make it a global though. I could put it under game logic imports everything. That's awkward. Can you show that circle again? It looked wrong. Oh, sure. So what's wrong with this circle? This is pi divided by 4, pi divided by half, 3/4 pi, right? Did you fix the sine and cosine? There should be a 0. Okay. There, is that better? There, is that programming language enough for you? Chat. Listen, I had a crash course on trigonometry today. I'm proud of what I learned. So the whole circle is pi degree. That's wrong. No, this is radians. So this is, pi is 360 degrees. This is 360 divided by 4. This is 360 divided by 2. This is 3/4 360. That's what that's saying. Pi is just the diameter times whatever, 3.14. That's how many times it takes for the diameter to go around this thing. That's why pi is 1 full rotation. So the whole circle is pi degree. 2 pi is 360. A circle is 2 pi radian. Oh! Oh, okay, that's how that works. Well, fuck me. It is 2 pi. Okay, we talked about this a second ago. So this is 2 pi. This is pi. Okay, this does look better, thank you. Pi divided by 2. And then, 3/4 pi. No, this isn't 3/4 pi. This is 1 and 1/2 pi, but you wouldn't phrase it like that. It would be 3 pi divided by 2. That's how you would phrase that, correct? It is not 3/4 pi. 3/4 pi is like here. Okay, this looks better. Okay, this looks much better to me, thank you. Okay, gotcha. So this is 3 pi divided by 2. Okay. Gotcha. Now chat, if we're gonna be converting degrees to radians, why do we have this? Because I get it where 180 degrees is a pi, but shouldn't it be pi divided by 180? Isn't that the correct number? Why do we have 180 divided by pi? Like, I get how we get this number, because 180 degrees is pi, so you're multiplying it by that number to get your number of radians. And if you wanted, I guess, the number of diametons, you would just multiply by pi. 360 divided by 2 pi? That's the same thing, right? It's 180 divided by pi. Good question. Thank you. Is 180 divided by pi. Okay, well, sure. We learn lessons every day. All right, let's look at our sine and cosine formula. It was line 20. Okay, this. So float velocity x is 5, so the speed of the bullets, multiplied by the cosine temp angle. temp angle being the variable degree angle over time. Now, why do we have sine and cosine? That's the question. So if we go back to our initial drawing here, which is the right triangle, this right triangle. No, fuck, it was this right triangle. Okay, this right triangle, boom. No, fuck, it was wrong, god damn it. I don't even know why I questioned myself. Okay, this, where this is theta, not a little smiley face or an Easter egg, it's just a theta. So theta, if this is the hypotenuse, this is the opposite, this is the adjacent. So we're saying the X value and the Y value are what we're gonna be changing like the bullet speed to be, right? That's why we have cosine and sine. So cosine and sine, how do we find those numbers? Now in our case, SOHCAHTOA. So ka is adjacent divided by hypotenuse. Well, no, but whatever, equals adjacent divided by hypotenuse. And then sine is so opposite divided by hypotenuse. Okay, that's all fine and dandy. But what's going on here? So we're saying our bullet speed is going to be the cosine of 30 degrees. Let's just say that's what we find. So, or 60 degrees, for example. So if our cosine is 60 degrees or whatever, it's going into 60 both ways. Is that the number we should be putting in, or should we be converting to radians? H is 5 in this case. H is 3. Oh, shit. Oh, that's so smart, chat. That's why you guys get paid the bid bucks. Okay, I got you. So cosine formula is equal to, in this case 60, is going to be equal to the A value. Wait, fuck. So adjacent divided by 5. 5 is the speed. The sine of 60 is going to be so it's the opposite divided by 5, which is going to be the sine of 60. So what's wrong with this? We're solving for A and we're solving for O, right? Which is correct because it's the X velocity, the adjacent, and the Y velocity, which is the opposite, right? So X is cosine, Y is sine. Cosine is A, Y is opposite. Yeah, so what's wrong with this? I think we did it right. Now that I understand what we did since yesterday, I understand trigonometry a lot more now in the 3-hour crash course I did. Didn't someone say in the earlier stream the SDL uses degrees, not radians? Multiply with 5 on both sides? What? Why? Is he using math H sine and cosine function? I'm not sure what you mean. Maybe there's an SDL sine and cosine I'm not aware of? I know C and C++ normally use radians for sine and cosine. I'm talking about SDL. Well, SDL is a C-based library. I would imagine they would use the C-based sine and cosine. If they don't even use it. I'm using like the C library, basically. Whatever the standard is. So A is equal to 5 times cosine. Oh. So this will solve... Oh, wait, I am doing this wrong. I am doing this wrong. So A, the adjacent, is equal to 5 times cosine 60. Okay, that's correct. That is what we did. Adjacent being... the X value of the speed that it was going to go by, how far X it's going to go. So it's 5 times temp angle. Oh, so we need to account for radians? Okay, I could try that. Okay, let's try converting it to radians. So 180 divided by m underscore pi. Copy. Multiplied by this. Now we are We are doing that in the sine and cosine angle. Yes. Okay, let's try this. That was worse! Wait, is it worse? How many bullets am I even supposed to be shooting right now? Hold on. I'm supposed to be shooting... where's my game logic? I'm supposed to be shooting... Hello? Oh my god, Gary, comment better. What the fuck am I doing? Where's my, Okay, bullets move, bullets render. Oh, wait, is that under my attack mod? No, I would have called the amount of bullets I'm gonna shoot, right? Oh, are we testing right now? Is that why I didn't do that? Okay, that's my attack. Oh, no, wait, I was right. Bullets? No, that wouldn't change anything. This is just the angle. Wait, where am I setting bullets? It'd be under game logic, right? Move, render. Oh, it would be under load game. Oh, that's right. Attack Nova 300. Oh no, that isn't right. That just creates the Nova attack, which is the degree angle we're gonna be shooting from. Projectiles. Where am I getting projectiles from? U int 8 projectiles. Call attack. Okay, where am I calling the attack from? Oh, at the beginning, right. We wanted it outside of the thing. Okay, my bad. So let's, oh, we're supposed to be shooting 20. What about 100? That is not accurate. Because it should go up to 255. And so if we shoot 250, actually, it is shooting 250 bullets. Oh, I just realized. Oh, there you go. It is shooting 250 bullets. It's just overlapping with each other evenly. Oh, interesting. 10 bullets. Okay. If I put that in my game loop, is that going to, is that gonna matter for like... Okay, so it's not randomized. Look at that trail. Isn't that weird? This is weird, right? Why? It's not even shooting 10, is it? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. How do I end up with 11 bullets? Is it this? Should it be less than projectiles? Is that what's going on? Okay, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Ah, okay. Well, that's one step done. So what if I change that to 20? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Huh. Wait a minute. You use a constant 5 times cosine sine, but it looks like the thing explodes. Like the radius isn't a constant. What's going on? It looks like he's setting it as a velocity that a move function later adds to the position. That sounds right. Wait. Atreus, hello, you're new here. Does set velocity convert from float to int? No. Under our set velocity, we take a float and it, well, it changes velocity x and velocity y, which happen to be floats. I think here's the problem. I think we're back to square one. I think SDL rectangle is our limitation here. I think it's because it only takes ints. And when we relocate the x and y value for those rectangles, I think it's converting it to integers. I think that's what's going on. Which means we're back to square one and we need to recreate rectangles as floats. Now, there is such thing as an SDL rect F, which is a float. No, wait, what? SDL, hold on, SDL F rect? There we go. There is a float rect, to be fair, but do we just change everything to, well, we're still gonna have the same problem in that they can't rotate. Quantized position. Hey there, woos, hello. Long time no see. Okay, anyway, I think we're back to the problem here where we need to recreate rectangle. I think that's our problem here, correct? So what happens here, just to be sure? Okay, so we have 360 degrees. We're gonna divide those 360 degrees by projectiles evenly. And every time we do, we're gonna make temporary angle. So in this case, if we shoot with 6 bullets, it would be 60 degrees. Make it equal to 360 multiplied by I, which is the current projectile count you're on, divided by... Wait, what? Wait, why do we do this? Hold on. 360 multiplied by I divided by 6. Is that the problem? Is M angle the angle between them? Yes. M angle divided by projectiles multiplied by I. Oh, was that the issue? That might be the issue, because we have issues where at a certain point they spawn over each other. Okay, what the fuck? How many are we shooting here? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Maybe 16 is overlapping now? But how does this end up happening? I equals 0, you divide by I, error. Well, it's C++, there are no errors. It's called undefined behavior, motherfucker. Okay, so this, for now, let's make this 1. Same problem. Is M angle the angle between them? No, sorry, I'm so sorry. Temporary angle is the angle between them. M angle is when we make the object attack, which in this case is Nova, so 360 degrees. The idea is then later we're gonna have an attack called Wave, and the only thing that's different is just the angle that we shoot at, so 50 degrees, 360 degrees, whatever, right? So there's some consistency in it. Did you manage to capture the frame rate? I ended up having to leave and couldn't see the end result. Oh yeah. It was easy. We just have a get tick 64. It's called Delta Time. It's a secret. Nobody's ever heard about it before. Delta Time is equal to get tick 64 minus current ticks if they're greater. Delay. I know this is not perfect 60 FPS, but for our purposes, it's fine enough. Read please, M angle divided by projectiles times I. That's what I did, didn't I? M angle. Oh, I did that wrong. I'm sorry. Divided by projectiles multiplied by I equals 0. Okay, so now hopefully this works. Okay, I think we figured it out. I think it worked. Katybug Raids was sick. Oh, thank you. Okay, everyone. Hi, I'm Gary the Goo Boy. We're making a video game right now, so I hope you guys like programming. I am Katybug's friend, or one of them, and we're making a little video game. We're making our own kind of pseudo engine. By the way, I just figured out this is correct. I think it's just rounding to the nearest like integer, right? So if I did instead of, what are we shooting right now? 20? Instead of 20, let's do like 6. We'll do that example, right? What? How does that even make sense? Wait, why does that happen? Okay, well now we're shooting 5 streams, none of which are in the top right, and we shoot off a nova of pew. What? You're recalculating the angle for each projectile. You already know your number of profiles. The angle increment would be the same for each projectile? Oh. Oh, you're right. And we just multiply it on itself, or we add it to itself every time. Oh, that's some big brain stuff. Thank you for pointing that out. I didn't realize that would be a thing. Do you guys like how there's a little collision box here, and if I collide, look what happens to my character? Boop, translucent. You can basically call me like Miyamoto, because I'm gonna program the hell out of this bitch, all right? Are I and projectiles both integers? I is a, wait, where were we? Attack. I is an integer, projectiles is a uint 8, which is, yes, a pseudo integer. It's an integer that goes up to 255, which is fine because I don't ever want to make this above 255 bullets. I would rather have it overflow to 0 than have it be like 2 million or something. Try to increase 5 to 100. Maybe it has something to do with floats. I mean, it probably does. I mean, we're gonna remake all of our rectangles today. So I mean, that's what we're gonna do right after this. So 100 bullets looks like that is not 100 bullets. Leon Hertzel, thank you for following. I appreciate it. Thank you, Leon. Your name reminds me of Kingdom Hearts 1. You guys remember that scene in Kingdom Hearts 1 where Leon goes, you know what? I just don't know. And he's in like the hotel room with Yuffie, and you know they fucked, but like it's a Disney game, so like it's hinted. Goobly, Metro Ham, hello. We're making video games now. Have you also, you guys don't see this, and I cannot explain why this is. Look at these oh, hold on, game's starting to lag. 1 second, let me do that again. Look at these bullets here. Look at this. It like bounces off the edge, but these don't. I have absolutely no idea why it does that. My engine is beyond like compare, all right? It is weird though, isn't it? Oh my gosh, I wish I could, there we go. Boop. I don't know. Ooh, C++, yes. C++ 23, we have modules. You guys, no naming errors anywhere. We're gonna have our own little sheet. The angle should be the same, but this is not. Maybe we should do a float for position. Okay, so you're saying under attack. Okay, M angle pro is int divide. What? Oh my goodness, so many people talking. You're recalculating the angle for each projectile. We're gonna change that in a second. Try increase 5 to 100. It didn't work. The angle should be the same, but this is not. Maybe we should use the float for position. Okay, so here's what I'm thinking. I think we're gonna make this stay as int, but well, that can just stay as that, huh? So what if we make temp angle like this, and then we make this plus equal itself? Is that ever going to be a problem? Is this a cleaner way to do it? What does that do? Oh, improvement. Actually, no, it's the exact same thing, but that's fine. That's probably cleaner anyway. 1, 2, 4, 8. No, that's not how that works, right? Oh no, that is how that works. Oh no. Wait, how do I avoid recursion? Oh, I know. Float temp angle is equal to temp angle. Listen, chat, let me cook. Plus temp angle. No, opposite. This should be temp angle. And this should be temp angle. Okay. All right. That is not correct. What? This is correct. I think. Shit, that's not correct. Wait, why does that only shoot off in one angle? How is that shooting 100 bullets? Also, we need culling. It starts lagging immediately. I've been thinking about picking this up on the side. I still got a lot to learn with C#. Oh, I have never learned anything besides C++ and SDL, so I got nowhere to go but up, baby. Think about, chat, I think I have become Superman of programming, because if I go on to like C# or Python or something, I'm gonna be like the wizard, all right? I'm gonna be like your IT guy. I'm gonna be so on course. Just shocked, hello. You never use temp angle in the sine cosine stuff? Oh, you're right. So this needs to be temp angle, and then we add to it every time. Okay. This ends up looking the exact same as before. Okay. Well, that's a thing. We'll just call this set angle. Try a small number of projectiles, go for multiples of 2, 4, 6. Okay, well, let's try it. Under our game logic. All right, let's try shooting 2 bullets, which should shoot at 0 degrees and 180 degrees. Okay, I did something wrong. Hold on, what did I do? Why does 2 make this goofy? So 360 divided by 2 is equal to 180. This is equal to 0, so this whole loop will run twice. Okay, so 180 plus equals... Oh, I should do that at the end, huh? No, at the start is fine. Oh, no, this does need to be at the end, huh? This needs to go, like, down here. Okay, that still didn't do anything. Did you build? Yeah, I'm pretty sure I did. Yeah, Nova, call attack. Oh, wait, I didn't delete the old one. Oh, chat. Oh, no. Oh, Jesus. Oh, no, I goofed. Okay, this needs to be 2. Okay, what does that look like? Well, we shot 2. Let's move that out of... Well, no, let's keep that in there. I like seeing the trails. So we're shooting 2 streams. What's the objective? Leon, we're going to be making a Toho game, shoot 'em up kind of thing. It's pretty cool. Korg, thank you for following. Kingdom Hearts Lord Hale. Hello. We're making a shoot 'em up where we're gonna have we're basically making our own engine, incidentally. So that's gonna be a fun little experience. But yeah, we're making like a Toho game. Just from looking at that, make character a little bit faster and smaller and make bullets smaller. Well, let's figure out the, oops, sorry, wrong formula. Let's figure out like the logic first here, right? Like my character, you know, we can, hold on. Well, this is the whole game size. I think the bullet size is fine. But like, boop. Okay, so. Bullets go, brrr. I can't roll my R's, I'm sorry. Try 1 bullet? Okay. Well, 1 bullet, in theory, what does that do here before we start? 1 bullet should do the following. 360 divided by 1. We also have to be careful. We can never accidentally have an attack of any kind because we don't have any error reporting on the number of projectiles. So if we shoot 0 projectiles, I think we break everything. So we have 360 divided by 1. So this is equal to 360. 360. This is only ever going to run once. This is 5 times 180 Empire. Okay, that's fine. That's fine. Where this is 360 times this. That's totally fine. I think. And then we add to this, but that doesn't count, or that'll never matter. There we go. We get 1 bullet, but why does it shoot up? That's the weird part. Why does it stream up and to the right? Also, we're gonna have hella good performance on this game, chat, because these are not getting cold. So we're producing 60 bullets a second, and we're still lagless. And we're going on like 15 seconds now. Oh, baby, we're gonna have some great ass performance. Okay. I was here yesterday to admire your commitment for this forsaken language. This is not forsaken language. It is the de facto language of video games galore. Gary, what about Unity and C#? Hey, what's that engine built on, motherfuckers? Shouldn't it be 360 divided by 180 times MPi? No, that's not correct. Because then you're having 2 divided by pi. 2 pi is just converting it into a circle. Wait. We can't just multiply it by pi. Oh, that worked! Wait, what? That's... something's wrong. Why does that work? Oh, is it because we're shooting 1 bullet? Is that the issue here? So if I shoot 2 bullets, it should shoot at 180 and 0 degrees. But it doesn't because it's only multiplying by pi. Okay, that helps. So now we're gonna try 2 divided by pi, or 2 multiplied by pi. 2 multiplied by pi. But we're gonna have the same issue, right? But it's gonna shoot on the left. Wait, what? Huh. We have to convert to radians though, right? Why are we only shooting 1 stream? Oh, there we go. Oh, because I was multiplying by 2. Was that the issue? Okay. Holy cow. All right. Temp angle times MPi divided by 180. No, we need 180 divided by pi, right? We solved for that earlier. If you mix radians and degrees, someone gave us the wrong degree to radian conversion earlier, a few streams before. Oh, is that over here? This? So you're telling me if I change this to MPi divided by 180, and then come over here to the attack, and then we do the same. But we have the issues with the direction of the bullets. It's not facing correctly. It's like when I do that, the opposite, we do face the correct direction. No, that was correct. What about ATAN 2? No, that's correct. ATAN 2 is minus 180. No, careful. Careful. We're giving it a negative value. So x, comma, 0 minus velocity y. Does that matter? Or I guess it would be negative, negative, ATAN inverse. Okay, that's fine. Never mind. That's not what you're talking about. So I think this is correct, right? So now if everything works and I divide by 6, now everything works. Oh, shit, we just solved it. Oh, there we go. Perfect. Okay. Now we're going to do the big test. 250. Okay. Here we go. I'm not even gonna, let's not even put that in the loop. Let's do that outside of the loop again, because that's a little bit spicy. Okay, let's try it. All right. Test number 1, Nova. Fuck. Okay, so something's wrong here. So 6 works fine. Yes. What if I have multiples, but we do 6 and 10? That didn't work. 6 and 3? That didn't work either. Interesting. So we have separate issues with calling multiple attacks. That is kind of glitchy. For now, 6 works. It's just when you get like high numbers, we fuck up, right? Can you do it in the loop again? It doesn't look completely symmetric. Oh, okay. We'll try it. Is that not completely symmetric? It looks pretty symmetric. That's pretty symmetric, guys. I mean, it may round to the nearest int, but like for our purposes, it's totally fine. You probably want position to be float. See how many you can do before lagging? I'm betting 100,000. Well, we're shooting 60 times 6 bullets every frame, 60 frames a second. Wait, sorry, 60 bullets a frame. Fuck, no. 6 bullets a frame, 60 frames a second. So 360 bullets a second. Right? No. Yes. Yes. Okay. 360 bullets a second. And we have no culling, by the way. The milliseconds you see on the top left here, the milliseconds is rising. So there is like time between each frame. It is increasing. But no, we're still handling fine. I think we can handle like, at this point, we're probably into like the 100,000 range, but there's nothing else loaded. So who gives a shit, you know? I hope there's no memory leak because that might have fucked my system. Hey, Gary, looking better and better. Nice, Nova. Well, still under construction. The northeast and southwest one should be aligned. That bend is more like float int error, which it might be. It looks crooked. Yeah, so does your mom, but I don't complain. So does your mom's spine. Catch it. No collision detection means super fast though. A process won't leak memory when closed. Yeah, well, it's C++. Don't underestimate me. So then we have issues where, let's say 20. Oh, yeah, this is int errors, huh? So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. So we're shooting 20 streams. But now we have issues where we're having like rounding errors because these should be a perfect division, right? You guys are right. So you're saying position Studer. What's up? So what's up? You're saying that what should be changed? Where's your text? You probably want position to be a float. Okay, what's position here? That's bullet, right? Position is an SDL point bullet position, which is under load game, which is, oh, not here. Wait, what? SDL point position. So we should have float position X, float position Y, position X, position Y, position X, position Y. All right, let's see what that changes. And this is going to be position X, position Y, which is set position. Set position is going to take float bullet position X, float bullet position Y. Why didn't we do this before? X, Y. Okay, it doesn't matter because render rectangle is going to change it all to an int though, huh? Yeah, it's the same problem. Okay, well, we solved our Nova issue, but now we need to convert all SDL recs into hold on. Using the Army's form here. Custom rectangles using Army Research Lab forms. More than a float to int error, as in you got another problem somewhere? No shot. You start with 2. Does it split evenly? Yes. Oh, that fix SDL point in set position. Oh, I did that, right? That's what I just did. Yes. No, I didn't. Yes, I did. Okay, sweet. That thing with 20 looked like it looped around a couple of times. No, it didn't loop around a couple of times. Yeah, it's not looping. It's, yeah, this is 20 streams of bullets, but that's what it's limited to. That's how much is in our for loop. It can't do more than that, unless I call it multiple times or something. Yeah, maybe it's like an illusion with the rectangles, but the rectangles should be rotated where it's shooting. That seems correct. Like, this is a perfect stream because it's like a 90-degree angle because we're shooting 20 of them, so it's evenly divisible. So we have like a cross of bullets. Yeah, it is kind of crooked, right? And I think that's where you get your rounding errors. Ooh, starting to climb up in milliseconds there. Starting to see some double digits. That thing with 20 looked like it looped. Maybe print out the angle, see if they increase correctly. Sure, we can try it. STD, C out, temp angle. All right, we can try that. Fuck, that wasn't smart. Okay, how about this? We call it once. Let's do that. Oh, Jesus. Okay, and then... wait. I did something wrong. Okay, grab this, move this here. There we go. Now let's go back to attack, and we're gonna temp angle, STD, endle, because we only need it once. Go. So this is each of the angles of the 20-degree thing. This is what prints out when we shoot out our Nova of 20 bullets once. 18, 36, 54, 72, 90, 108, 126, 144, 162, 180. This is correct. It's supposed to be 8, right? Hold on, let's do our math. 360 divided by 20, 18. So it's 18 degrees per angle. This is correct. Oh, a lerp between 0 and 360? What? The one going right and the one about isn't the first and second line. A lerp is a classic game dev word? Well, I'm not a classic game dev. Do I look old? No, I'm young and youthful and full of energy. So you're saying try 6. Let's try it. So this should produce 60 degrees per angle. So 60, 120, 180. Go. 60, 120, 180, 240, 300, 360. There you go. Correct? Everyone happy? Am I not correct? I was correct. Yeah, it is at the correct angle. Now, to be fair, it may render differently because this is only the angle that we have set it, not... In fact, let's do this. Instead of printing out temp angle, let's print out B velocity X and then space B velocity Y. And then let's see what prints. So here we have 2.5, 4.33, negative 2.5, 4.33, negative 5, scientific notation. So that, you know what that tells me? That's 180 degrees. There's like some like error here. That should be like undefined behavior because we're giving, because I think it is it sine that cannot do 0 and 180 degrees? So I think that's where it's getting undefined behavior from. And then we have this, and then this is 360 degrees. This looks correct though, right? It is a float, so that's why we're getting some weird numbers, but that's fine. It's just these should be like undefined. Is this look correct? I can't tell in radian. This is correct, isn't it? I mean vector. What is M angle? In this case, M angle is 360 degrees. So the goal here, by the way, is that we're gonna have different attacks, and the only difference is the angle that we shoot them at. So the object angle here, because we're shooting a nova, is 360 degrees. That's where we get that number from. Chat, would it be smarter to just convert angle immediately into radians? Would that just make everything easier? Well, no, that's not fair, because when we set the angle of bullet, we do it after setting the velocity, and then set angle happens with that new velocity. So velocities, oh wait, are they already radians? They are. We already convert. Wait, does this not need to be converted to no, it must be converted to radians, right? It has to be, even though it already is, right? Because this, the inverse tangent will give you a degree amount, even when you calculate velocity with radians. I'm 99% sure, and that's why we have to convert, I think. So this is correct. The only thing is I may do something like this. I kind of want to put like, if this, like I almost want to account for 0 on both of these, 0 or 180 on this one specifically. So like, if, I don't know. I feel like there's room for like not feeding the information garbage to the computer, which is this undefined behavior. That shouldn't be there. I almost want to like feed it like a hard number or something. Aton 2 will give you a radian number. So why are we, oh, are we converting out of radians? Is that the point? So if I just delete this, what happens? The exact same thing, except the angle doesn't change. It just shoots out straight up. Oh, that should be a divide, not multiply? What, here? No shot. No shot, you're correct. Yeah, okay, that's not correct. I was right. It was multiply. And now when we do that, it rotates. That's not undefined behavior. That's standard floating point errors. Well, tomato, tomato. They shouldn't be there. Well, not tomato, tomato, but you know what I mean. They shouldn't be there. I should account for this whenever we consider like, because that's just asking for trouble later, right? Like I should have not error reporting, but I should have it where it's like, if it's equal to 0 or 180 on sign, then don't do this, you know? In fact, if we shoot 4 instead of 3, watch what happens to the to them both, because you'll see it both ways. See? So you have error reporting on the cosine value, error reporting on the sine value, error reporting on the cosine value, error reporting on the sine value, because we're rotating 90 degrees each time, and that's why there's issues. Or not a whatever, a float point error or whatever. Const float rad 2 degree equals 180 degrees fly. What? Const float degree 2 rad equals pi 180. What are you trying to solve for there, Kahorga? Is the float a degree or a radian? Nobody knows. Which float? All of my numbers are floats right now. You reuse those whenever converting. Oh, do I? I didn't know that. Maybe try turn position to float. This seems to be a float int issue. We already did. So under our bullets, our position here, we've already converted to floats. So that's already solved for. And then we call set position when we move. Set position is also converted to floats. No, you didn't. You still use SDL rect and oh, right. No, we didn't. You are correct. The floats is changed, but this is still an int. All right. So I think what we're figuring out is we need to make a new rectangle, which means we need a new module. All right. So we're going to do something very unique in that we're going to listen to the United States government rectangle. So we're going to call this float rotate. No, we'll call this rectangles. We'll say that. That's going to be our whole module. All right. So we're going to have a module. We're going to call it rectangles. It's going to be a module primary interface. All right. So what we're going to do here is we're going to do something kind of unique. This is the Army Research Lab called Creating, Positioning, and Rotating Rectangles using C++. And we're going to be using this. It's quite short. It's not that long, but we're going to learn it together. Boom, 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 boom. There we go. All right. Introduction. Somebody at me with what Gary is doing. We're making a homemade rectangle. Just remove line 17 and put float position X, float position Y, float render size width, float render size height. No. Wait, I can do that? No, I can't do that because the renderer will only accept renderer only accepts SDL recs. Is there a SDL render copy XF? Oh, there is. Oh, shit. Okay, hold on, based. What do you accept? You accept floating recs. I can't make my own rectangle. I need, well, at least anything that needs to be rendered. Could I just convert render rect into a floating rectangle? Can I just like do that? I think I can. Input sprite size needs to be a rect. And then this is gonna be render XF. This military code, holy shit, Lamau out of 10. Hey, it worked. It's from 2013. Yeah? What's wrong with it? Listen, spoiler alert, C++ was past its heyday before some of you were even born, okay? So let's not make fun of a paper that's 11 years old, all right? Okay, so, render copy X, FF. So all this is now a floating point. So if we go to our load game module, we're just gonna delete that rectangles module. We don't need it anymore. Come back here. This for now is gonna be bullet size needs to be a float. 'Cause that's gonna be the rectangle, right? Sprite pellet doesn't work. What? Wait. Sprite, floating rect, rect. Sprite. There we go. Now it works. Okay. So if everything works. Okay. Okay. Let's try 20 again. Oh, that looks so clean. Oh, hold on. Hold on. Did that just solve everything? 1 second. That looked clean. Okay, that's beautiful. That is the most beautiful goddamn thing I've ever seen in my life. Oh, it's so nice. Oh, it's so pretty, chat. It's like a flag. No, I think you're right. It was just floating point errors. So now, chat, here's the real test. Let's try 100. Oh, shit. It worked. Oh, my God. There's so much lag. Oh, Jesus. Okay. Okay. It worked. We just solved the problem. It was floating points. That was it. That was the only issue, I think. So let's do this. Let's do that. Delete that. Let's try to shooting 100 and boom. There we go. We have 100. Okay. Can I do 255 at max? Go. Oh, shit. Chat. I think we just figured this shit out. Now the question is, why is it that when I have two of them back to back, nothing happens? Did two of them shoot out? I can't tell. How do I tell? Oh, I guess I could have two different sizes, to be fair. Hold on. So I could have like size 4 and size 1, 2, 3, 4, and we'll do size 8. No, wait, that's a terrible test. 6. Oh, there we go. They both shot. Wow, we're actually done with Nova. We're done. All right. Oh my God, I can't believe it. That took us 5 hours, and we finally have an on-demand Nova that can stack with each other, that can go up to like 250 or something stupid. Oh, it's so beautiful, chat. It's so nice. Oh, it's so beautiful. And if I needed to, we can see all of the floating point errors from having like 180 degrees and shit. But there you go. Sweet. Awesome. Okay, that's done. Now we just need to spawn it on the enemy, I guess, on the on that point. I guess attack can import enemies and then use where is it? SDL point shoot location, which will handle all that stuff. We might have to convert these to floats too, to be fair. But yeah, it seems like it was a all along it was just floating point rectangle errors. He tried to fix projectile angle. It didn't look right. It's a bit crooked now. We suspect. Yeah, no, we fixed that. Yeah, wow, we're done. It looks so pretty, chat. I just want to keep looking at it. It's so nice. It's so beautiful. Oh, you know what we need to do? Make it so these bullets can actually collide with me and not just be stuck in the corner. Okay, that's the next thing we're gonna do. Okay. So now, we need the hitbox to also move with the bullets, which means these need to be floating point boxes. Collision, control F. This box needs to be an F rect, which is good. So that's done. So now they're all floating points, and this floating points doesn't work. Why? Initializing conversion from double to float, possible loss of data. Double to float, possible loss of data. Uh-oh. Collision. Why? Why does collision turning into a float rectangle cause issues? Where am I using this? This here, update collision. Well, these were already floats. Is equal to float.x. That shouldn't change anything. Build errors. Oh. This only accepts SDL rec. So we need F has intersection? Okay, so it's a collision issue. SDL has intersection is, oh, there we go, has intersection F. And now you accept only F rectangles. Okay, so now we need the hero to be updated, which is fine. I wonder if there's any reason not to use F recs for everything. Is it just, you know, size issues? F rect. Load game now needs an F rect. Hero size is going to need that, right? Yeah, we will. Okay, and then this needs render copy XF. Okay, now we need Control S, go. Okay, SDL draw is going to have an issue because list containers now contains that. Float. Man, I'm glad SDL took care of all the hard shit for me. Render clear. Okay, go. There we go. Now everything's afloat. Hold on, something's wrong. Why? Oh no, it's just the graphics. Okay, I was about to say, why does the bullet on 0 degree line look different? It's because it just overlaps everything. Because it goes twice, I think. Oh well, that works. Sweet. You generally don't need doubles in game development. It wasn't just floating point, the temp angle was also wrong. Well, we fixed it. Holy shit, nice, you got a pattern already. Joe, hello, yeah we do. Hell yeah we do. Well, now the point is to get the collision box on the bullets to actually follow the bullets. So we have our collision working again now that we've changed SDL to accept float values on all rectangles. Now we need the collision box. Okay, so the render box is updated. When we call set position, I think this also needs to move with that, right? And then update collision gets called. It's the same thing. So collision.x is equal to this rectangle plus this. But then it never moves. So if I call all of that and it's on a per bullet instance basis, why does it never move? And it's just stuck in the corner here. Why is that never changing? That should go with the bullet. So what's wrong here? So the X value and the Y value of this collision box is going to be equal to the rendered X and Y floats. They're all floats now, plus this. So what if we just get rid of these? Doesn't do anything. There's nothing wrong there. What do you want to see? Well, I don't know how well you guys can see it, but there's a little red box in the corner up here. When I hit it, my character goes transparent. The problem is that little box shouldn't be there. It should be following every instance of the bullet, and it doesn't. It seems like all of the collision boxes have the same X and Y value, which is 0. That doesn't seem correct. In fact, if we were to change bullet collision size from 0, 0 to bullet size dot X and bullet size dot Y, you would see it in the middle. Ugh, what? Too many initializers. What? Oh. So yeah, now you see it in the middle, right? But the X and Y value are never changing with the bullets. Do I have to? No, I don't have to call it separately in the attack module because it already calls set velocity and set angle. And then it pushes back. And then our bullets, set velocity, set angle. So that all works. But then we call, under our game logic, we render the bullets here. We call them. Okay, so now they exist. But later on, we actually call set velocity. So we set, oh, that's the enemy ID. There, we set every individual instance of bullet to move, and then we render. So under our bullet module, move calls, we create two floats, have our rendered rectangles equal to those values, increase them by velocity, so the distance they're gonna move. We call the set position function. Set position calls the rendered rectangles to be equal to these new floats. So you're increasing the render distance, or the where the bullet's going to be rendered on the screen by the new velocity. Then we update collision. Updating collision updates the X and Y value of the collision box based on the X and Y value of the rendered rectangle plus these. I don't know why we have these to be plus, but there you go. So that's kind of the logic, remember, is we're kind of going up a chain. But when we render the thing, the X and Y values never change, even though this is like an overlapping, like, I don't know, however many bullets we have, 100. This is like 100 red boxes that are just on top of each other. And so the X and Y values aren't changing. You only draw that little box for one bullet. You need to draw boxes for all bullets? Well, if I get hit by the bullets, it's still, yeah, there's no collision. So shouldn't that have collision? Yeah, none of them have collision, but this does. Isn't that weird? I need to get something to eat. Have a good rest of stream. Gary, see you later, Studer. Thank you. Line 52 only draws one box for the template build. Template bullet. You need auto bullet. Well, that doesn't matter. Better yet, you should draw the box and bullet render. Well, it's not going to change anything. Like the rendered, there's no information under there. It's not like the drawing actually changes anything. You only check collision, that little box, for one bullet. You need to check collision for all. Oh, wait, I know what it is. We're not checking for the vector of bullets. We're checking for the vector. Are we? Let me think. Is it like an iterator issue? Line 34. Anyway, I'm out. See you later, alligator. Or are we rendering? No, bullet list isn't gonna be the thing we do, right? The address of vector. Oh, so maybe under game logic, instead of calling for the collider, where is it? Where's our collider? Our collider is render clear, render present, get ticks, hero collision, this. So now instead of bullet list, we call spawn bullet. So now that is what we check collision with. Oh, and it worked. Oh, it worked. Oh, shit. Okay, okay. Now we're cooking with fire. So you're right. Instead of checking the draw recs here, we're gonna copy. We're gonna, okay, hold on. Set render draw color 255. Let's copy that. Put it in bullets under our render. And then also copy our draw F rectangle. It's gonna be, no, I can't do that. I can't do that because it'll oof, redo. I can't do that because it will, I can't call the renderer under this. It doesn't work. I don't have access to the renderer there, but I know what you're saying. You're saying I should have that loop there, right? Yeah, okay, that's what you guys are saying. So what you're saying is have that exact same list here. Draw the hitbox, thanks. Yeah, so you're saying for every instance of L bullet, do this, spawn bullet, list containers, whatever, and then do like render there. Okay, I could do that. This is list containers dot spawn bullet. Bracket. This will be doing this. Go. Oh, forgot a semicolon. Oh, no, I didn't. This was right, I think. Expected an expression. What? Oh. What? Missing a semicolon? Where? List containers is correct, so this is fucked up. Wait, what did I miss here? Is it bullet? No. Oh, 4. That's what I'm missing. Ha ha ha. Okay, all right. No hitboxes. Okay, I'm no longer deaf. Where are we at? Oh, we're making novas. We just done check for collision for the list of spawn bullets. Now we're drawing the hitbox for visualization. Yeah, it's a for loop. Now we'll go back to auto here. Maybe that's the difference. No hitboxes. Also, how are we still drawing the one hitbox? How do we even do that? Yeah, we're still drawing that one hitbox. Maybe instead of bullet list, we draw from spawn bullet. Go. Okay. Oh, it worked. It worked for one bullet. I don't know if you guys saw that. It worked for the 0-degree bullet and that's it. But it did collide otherwise. Okay, okay. Can we just set the bullet speed to like 1 now? Is that like a thing we can do? Attack module. Okay, let's just do like speed of 1 and 1. Okay, cool. So you see the little red box right there. That's where the collision is. Or well, they're all collision, but that's the only one that renders. Okay. 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 L bullet M collision. Yeah. L bullet M collision. L bullet M collision. Oh, so just get rid of bullet ID? No. Oh, you're just saying this. Oh, does that work? Yeah, that doesn't work. Yeah, because it's changing. Yeah, because it's not a member of load game data. Spawn bullet is, but M collision isn't now. You don't need Atlas containers. We can't see the thing anymore. Yeah, I know. Maybe you don't need Atlas containers. You're saying this should be just L bullet. Wait, that works? Oh my god, look at all the hitboxes. Oh shit. Well, there we go, chat. Good job. You're pretty dang smart. There's our hitboxes. You guys can't see it very well because there's so many bullets, but yeah, there are There are hitboxes, and they are very not rotated right now. So now we need to rotate them based on the bullet, because they're all very flat rectangles. You're already iterating through the list of bullets. Just grab the rect of the bullet. Did I say list containers and bullet collision? No. But it looked like it needed it, so I added it. I made it. Not better, but in my heart it was better, okay? Should the hitboxes be distance-based? Why not make hitbox circles? Because circles are complicated. I would rather 3 loops, use 1. Haha, this is so wasteful. Yeah. True, true. Here, you know what? I'll make it clean for you, chat. Enter, 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 enter. Move this up here. Boop. Like that. Delete that. Move this up here. Boop, 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 boop. There, does that make you feel better, chat? Is it cleaner for you? Is it doing something for you? Is there an issue? Oh, semicolon. Wow, look at that white space use. Yes. Yes, and based. He said it makes it clean, and he actually made it clean instead of changing random things. I'm learning, I'm learning. Okay, okay, okay. So now we have hitboxes, but they're not rotated. They need to be rotated, though. I mean, to be fair, they're not really matching on the bullet necessarily either. The X and Y value actually needs to change on that. It's width divided by 4 on both ends for the X and Y value, because I don't want it to be at the same starting point. Although we could just make it like the same. What does that do? I mean, I don't hate that. Oh no, it's horrible. Oh no, it's so bad. The worse it goes on. Okay, so this needs to be the Y value needs to change. It needs to be like the opposite end. It should be like 0. That didn't work. Holy shit. Interesting way to potentially track collision. X1, X2 times what? Move shouldn't be in a separate loop, and above all the rest stuff. I guess this is fine for now. I mean, it really should just be one big function here, because it just chains into one after the other, but whatever, it's the same thing. You're right, it is okay for now, but yeah, this can all be moved under one big function called, you know, update position. A vector of the direction for it right. A unit vector to get the angle, I think. Or just use a vector library and length a minus b. Gary, what the fuck? Also, line 49 could be auto. Yeah, how about I automatically put my foot up your ass? Bold White Dragon, thank you for following. Thank you. Aw, are you a programmer or a VTuber fan? Usually, a lot of people who watch me don't watch other VTubers. I don't know why. You actually know me? Are you amongst the bot? Are you... I know quite a few people who usually make new accounts because they're little trolls. I'd rather you didn't. I don't disagree, but I usually handroll my own vector header rather than faff with it. Do you know Muthu Vishal? That is not your name. Is it Muthu Vishal? I know your name. You watched me in the Geometry Dash days, right? I think it was either that or Stardew Valley. So what are we doing now? We're rotating hitboxes. But isn't this already taken care of here? Why does my rendered rectangle rotate? Oh, because we're applying angle to it. Oh, so we need to account for angle here. So do I add angle to this? No, that's the X and Y value though. Oh. That's pretty close. It's the opposite direction now, to be fair. So now we're gonna take it where it's divided by 3. There we go. Now we're on track with it. Okay, that's a very good bullet. Oh, wow, I nailed that. That's perfect. Okay. Okay, so that's perfect. So now we need to apply to the X and Y values some rotational value. So angle should get applied here. Because angle... No! This needs to go into the attack. So set angle applies here. Then we push back. So can I not do like bullet... update collision? Because set angle applies the angle. Set velocity takes care of this. We call move on every instance. Oh no, the angle is going to be different every bullet, because angle, we're going to have a bunch of different instances of the object bullet. So maybe this is like, I don't want to plus or minus this, do I? I guess I do. So plus angle, I guess we'll try that. See if that makes a difference. That crashes. Oh, because you don't know what angle. Oh no, you do know what angle is. Angle's a float. Warning, warning, warning. Why? What's going on? Bullet has no member list. Oh, whoops. I don't know how I did that. There we go. Now we'll. Oh my God, what did I do? That is the coolest shit. Chat, hold on, I'm gonna show you something. Look at this. Look at this. Look at these hitboxes. I don't know how I did that, but it's cool. Okay, so that shouldn't work. Where's my bullet? There we go. You shouldn't hard code the offset of the collision box. Yeah, I know. We can I was about to use the word decouple. We can separate it so that way we can have like some ability to make new bullets. Right now, I just want like the angle to apply. That looks like an A sine graph or inverse sine graph. Maybe we accidentally made it. Maybe that should be a custom pattern. I don't know. Let's get to the point where we can rotate shit. What if you represented bullets with 2 circles and a convex polygon that overlaps them? Buddy, we're messing with rectangles, okay? Let's not get calculus up in here, okay? Oh, hold on. Let me bring up paint here. Did you guys know? I just found this out today. Did you guys know this symbol or whatever? That one in math? Did you guys know that this is just a for loop? I didn't know that. It's a for loop. I don't know. Maybe I'm a moron. I didn't know calculus was that easy. I say we do circle for everything since easy. I'm sticking around reading the dot mill paper. It's so funny. What, you don't like having a rectangle be represented by an array of 8 elements that you then multiply into a 2D array to rotate it? Your voice is like this. Yep. It is. This is how I sound in my day-to-day life. I don't make shit up, chat. This is how I am. I'm reading the Jaeger guy's other papers and I'm falling over laughing. Well, he works for the military. Submit your own document. Well, to be fair, does the military use C++ anymore? I don't think it does. I think, oh no, it still does. That's like, C++ is still government shit, right? Yeah, it does. SDL frect cannot store a rotated rectangle because that one means store XY with height. If you want a rotated rectangle, you need P1, P2, P3, P4, and once you rotate it, it becomes a polygon. Wow, that sounds like the military paper and what they did. So what you're saying is that under the attack, I need to update the collision every instance. No, it's a whole separate polygon. Hold on, not polygon. It's a whole separate, like, it's part of the object, right? So no, I guess I can put it in this. So could I not? What do I do here? It's move calls set position calls update collision. So the rendered rectangle has nothing to do with the attack here. All this does is set the velocity and the angle of the attack. So under game logic, do we add a separate thing here? Will we have like L bullet? No, move automatically calls it every instance. Move already updates the collision to be correct every frame. So that's why this works. The problem is the only thing I need is to apply angle to every instance of the collision box. That's the only thing I need. Which tells me, because angle is just a variable that exists in the whole like struct, because every instance of bullet is going to be on that like vector to be rendered. They still use tech from the 70s. True. Floppy disks because they're reliable. F-35 is made with C++ for its flight software. Wow. I can only imagine how much the company that got paid to do those pointers. Make an STD array float for M collision and another STD F rect M base collision. SDL has intersect F, won't work on a rotated rectangle. What? Hold on, let's read documentation. SDL has intersection F, which determines whether two rectangles intersects with float precision. Pointer A, pointer B, an SDL F rect structure representing the first angle, second angle. Oh, you're right. Oh, that is so cringe. Oh, that is so bad. Hold on. We might end up using that military paper. We might unironically end up using that military paper then. Because even if we can rotate the collision box, we still can't check for collision. And down bullets are a problem here because sideways bullets, they're perfect. It's the bullets down under that like fuck me up. Because you can see here, like, hold on. You can see here, fuck. Okay, the collision box on like 0 degrees is perfect. But at 270 degrees, it's the complete like sideways. There's really no way to rotate those boxes. Oh, that is so cringe. Like I said, circles. Is there really no easy way to do this? You will need to rewrite that for convex polygons or less generalized version of rotated rectangles. Well, how about this? Can we even rotate the rectangle? Is that even a thing we can do? Yes. We can rotate the rectangle because the sprite is already rotated. And the sprite's not even a float. It just uses SDL rect, right? So the sprite, if the sprite can relocate based on given information of like angles and shit, surely we can update the collision box, which is also a flow rectangle, to be the exact same way. Is it because we're not applying the velocity to them? No, it is. These get updated with the velocity, and then this is the velocity. Why? The only difference I see is that every rendered copy gets the angle applied to it when it gets rendered. And that's how you rotate the sprite. So how do I apply this render angle, which is this angle here? How do I apply that to the collision box? X and Y val. Oh no, it's worse. It's even worse than that, I think. Because the renderer already handles all rotations in the render. We're not actually applying angle anywhere except right here. In fact, if we change this to 0 and nothing else, they're all perfectly vertical. That's the only time this ever gets applied, is applying angle to the render. And that's how all of them rotate. So is there no way to just rotate the collision box without necessary? Oh, but it doesn't matter because our collision engine currently only... Oh God, that's so complicated. Okay, oh God, oh Jesus, okay. Oh, do we have a new function then called set angle? Like set collision angle or something? Oh Jesus, okay. Circles are the easy way. Okay, hold on, just for shits and giggles. Void set collision angle, which takes no parameters, and this will you already have angle. Why do you need to set the angle? Well, not set the angle, but apply that angle to this collision box, and I wanted to call it every function for loop. So every single bullet gets, you know, we set the angle and then we apply like bullet set collision angle or something like that. That's like my idea behind it. So now we have void set collision angle, where we apply the m collision underscore dot x equal to something, m collision underscore dot y is equal to something. I just don't know if that's just, you know, plus equals angle. No, that's not right, because we've already fucked around with that. Yeah, this will do some weird shit. In fact, it doesn't even run. Bullet class has no member called set collision angle. Yes. Oh, save it. Yeah, and the issue is the and the issue is the collider. Look at that. Oh man, that sucks. I think we have to make our own collider that is separate from what SDL offers, because we're getting limited by SDL here. And I think that's important, right? I think it's important. What good practice that would be, chat, to make our own R2 rectangles of any rotation, R2 polygons of any rotation, any value. Are they intersecting with each other? I bet that would be good practice for us to make a function like that. Joe, you just need a radius on the hero and the bullet. This is great. I'm surprised how similar it is to my personal style. This yarn is awesome. Damn. Stream buffering? I have 9 frames of rendering lag, but that's because we were running the game. So if it's buffering, it's on your end. You need to turn M collision to a point and then rotate each point around a pivot and then store them. Oh, would that work? So hold on. I'm gonna bring out paint here. I'm gonna flashbang you guys. So you're saying instead of doing what we're currently doing, which is taking this rectangle and then rotating it, the whole thing, you're saying let's take a rectangle, pin it to a point, and then rotate the point? Won't the collision box still have issues? Aren't we still gonna have issues with like diagonal rectangles in the SDL collision F function? Like we're still gonna have the same issue, right? This problem is the same as asking if any 4 triangles intersect. Is there a triangle in triangle checker? Ooh. Yes, you're gonna have to rewrite the collision detection. Fuck! It's time for matrices. I mean, we could. Oh, wait, chat. Does that mean I get to fuck around with vertexes like SDL vertex? Oh, I've always wanted to fuck around with that. Because then you can have vertex A and then like boom, boom, and then like vertex B and then vertex C, and then this makes a triangle, and then we fuck around with it. Ooh, that'd be kind of fun. Just use STD array float 4. You know, that sounds awfully familiar to this guy's solution. Although, to be fair, this guy basically makes a collider for you. Because he he's like in rectangle C, if rectangle A and rectangle B are colliding, then return true or something like that. So his solution is to make, oh, look at that, a 2D array with 8 elements. And then you just test if everything is collided with each other. Wow, he has doubles everywhere. Intersects B, true, C, false, A, false. Wow. I mean, if we're gonna be making a rectangle collider, like at this point, oh, you know what? This wouldn't work either. Because it's gonna suffer from the same issue where, well, 1, it's doubles. 2, it's on a 2D array. Oh, well, look at that. That worked. So these are what? Oh, I see. So n uniformly distributed rectangles, and then this is randomly generated points that are the interior to 800 uniformly distributed rectangles. Okay. Based. And it's the same rectangle image, it's the same map. The only difference is that what he's doing is that he's making a bunch of points inside of the rectangle that are now highlighted, just to show that you can sense the interior of every rectangle. That's cute. It provides rectangle 2D namespace. There you go. Now, this, if we just copied this and just implemented it as a header, it would actually solve all of my problems, but we wouldn't learn anything, right? We wouldn't actually like learn anything just copying and pasting this. In particular, I would really want to read, because all I saw was just the practical, like, here's what we're doing. I didn't actually look over the code. It looks like double M4 O2 is equal to R0 plus R2 plus R4 plus R6, which is the first rectangle, divided by 4. See? You're rotating a round of angle. Oh, you can rotate through this. What the fuck? Holy hell, that's a mess. Ah, yeah, but see, this is what we're wanting, right? Is to rotate around the point. You know, you guys are making fun of this, but I feel like the military knows what it's doing. I feel like they're correct here. So what is this? The functions described in this report operate on rectangles that are stored on an 8-element array, where array R is defined as Rx, R. Why are there 8 elements in a rectangle? Why would a rectangle want 8 elements? X, Y, width, height. And maybe like destination rectangle, I guess? He does know what he is doing too, which makes it funnier. Well, I mean, they do make these reports for idiots in the army. So, I mean, I'm not calling people in the army idiots. I'm saying like anything like the military does, they make it for like the lowest common denominator. Like the way they teach you to shoot guns is like the most like basic way to get you to hit your target with like so little understanding. You can just do it. It's the same thing here. This is not for the army. This is for the engineers who work for the army. 4 points, each has XY coordinates. Oh, that's unique. I don't know if that's smart. So he's saying, wouldn't it be better then, instead of having a bunch of values in an array, wouldn't it be better to have a struct that's like point or something? And that point is defined as 2 values, X and Y. And then you have a vector that contains 4 values of 4 points. Wouldn't that be better? I don't know. For me, that would be easier to read. No, it's fine to be an array. Oh. This is for the engineers who work for the contractors who work for the army. Oh, cute. Anyway, you guys are making fun of this, but like, what is bad about it? I feel like it solves all of our problems. So he's saying how to, translate that rectangle from there to there. I feel like it makes sense to me. Rotate a point, which is what we want, which is theta, which is perfect because that's what we're working. It's like, oh, trigonometry. Nobody's making fun of it except you and you guys. It's just some of the strangest looking style of code I've seen in my life. It's impossible to read. Have you even seen GNU style? Okay, so I think what we're gonna do. Oh, chat, that's gonna be so hard to fix. The thing is if we have this rectangle module, we need to substitute all. Okay, here's my issue, chat. This is the issue I'm having, okay? We cannot actually substitute all floating rectangles with this new rectangle module. That's not what it's for, because how we're rendering images onto the screen is through hardware acceleration via SDL rendering, which requires SDL rectangles. Now, the difference is that we're not going to be using this new module of rectangles in our logic for anything rendered on the screen. We're going to keep our floating rectangles for that. The only difference is we're going to use it for anything collision based. So instead of having this function here that SDL tests for us, we're going to have our own game logic that tests collision via the hero, any bullets, the enemies, all that. We're going to have our own homemade floating rectangles that will rotate around a function and, test collision around a function we made, because that's more game logic-y. So that's going to be so involved. Oh, that's going to take all fucking stream tomorrow. Chat. Oh, geez. Are we stuck until then? Code Toil, hello. Circles are super easy, trust me. Okay, well, some of us didn't take trigonometry, all right? Most games use axis-aligned bounding boxes, which are rects with no rotation. The problem there, I know exactly what you're talking about. So, for example, how do I implement this? If we just multiplied this by, well, that's velocity x. How do I change that? How do I change the collision box? It'll be under bullet, right? If we were to make this 0, for example. This is what you're talking. Oh shit. Hold on. Oh god, I didn't apply floats and shit. Hold on. Okay, go. Fuck. Okay, hold on. Oh, whatever. I know what you're talking about. We did that earlier incidentally, okay? It's fine. Don't worry about it. Okay? We're okay. Whatever. We did it earlier. Now there's issues with like the collision box and us rotating rectangles and stuff. Oh, it's gonna be so much to get there, chat. Oh, do you remember Pythagorean theorem? Yeah. A squared B squared equals C squared. Hitbox memes are AABBs. No, we're not gonna do that. What we're gonna do is not circles. We're not gonna take the easy way out. Chat, if I wanted to not worry about this and just make things easy, I would be using Godot or something. I would be using Game Maker. I would be using not C++ with SDL, okay? You can use this to draw the rotated polygon. What's up? The issue isn't drawing. It's the actual logic of the collision box. I can draw whatever the fuck I want on screen, but the logic of the game, the collision boxes, cannot be rotated, or else SDL has intersection floating does not work, which means we need our own rotating rectangle collision box function, homemade, that we have to make, which is fine. We can do it, but I need it. SDL array or STD array SDL 0.4. Yes, that is the exact same thing the army paper is proposing. This. What you just described was where is it? Right here. So he just does an array of 8 points, which represent the X and Y values of each side of a rectangle, right? You are saying SDL 0.4, so 8 integers of 4 points. It's the same idea. So it sounds like this whole thing is based, and we're gonna follow it pretty much on track. The only difference is I may use floats instead of doubles on his logic, and we may have like our own struct for this instead of 8 points, because that looks confusing to me. I don't want to make rectangles with 8 points. I'd rather have like 4 structs called, you know, rectangle angle or something, and then just insert that into the vector. But anyway, that's the point there. Also, we should not be using vectors. You're right. It should be an STD array, because that the values will never change. We don't need to push back. We don't need to resize. It's just an array of 4 points. You are correct. Position 1x minus position 1,2 squared. Oh, that's to rotate, Coattail. Oh, sure, but let's rewrite collision detection next stream. Maybe now we can try to rotate the collision box and draw hitboxes. We can't rotate the collision box. In fact, that's what we're doing right now. That's why the program won't run. It's because SDL has intersection F will not. There's an error with this. That's why there's a giant red circle here, because it won't accept rotated rectangles as a value to test against for collision. In fact, if I just delete this, it'll run now. What? Set collision. Oh. There, now it runs. So now we have our hitboxes. They don't do anything because we deleted our collision. But now we come back here to collision. We paste it. We run it. Oh, because we're not rotating the rectangles anymore. Okay, because I deleted that because we deleted it. Whatever. You guys know what I mean. Yeah, I know what you're saying. What's up? I get it. But we need to rewrite collision detection. All right, that's what we're doing tomorrow. Now, you know what, chat? When we started this, I was like, oh man, what's the big deal about collision detection? Why are all these developers like complaining about it? Meanwhile, like the biggest issue I've had is collision detection, because I didn't realize like it would be so difficult to like even rotate a rectangle. It's so weird. Like I just didn't think that was gonna be a thing. Anyway, that's it. that's everything today. It's a short stream today because I have to go and wow, nice background. It's a short stream today because I gotta go do something, but tomorrow we're gonna have a fun. There's a fast math way. If you want, I can send you on Discord. Otherwise, you can just show me tomorrow, Joe, because we're gonna do that tomorrow. It's like we're gonna do all the collision shit tomorrow. All right, everyone. I know it's a short stream today, but hey, come here. We stream for 2 hours, okay? So give me kisses. What are you doing up there, chat? Don't hide from your obligations, okay? Come here. Give me kisses. See you tomorrow. Have fun. Have a good night. Stay healthy. I gotta go do something that I'll probably talk to you about tomorrow. Okay, we're gonna probably have a longer stream tomorrow. We're gonna remake collision boxes. We are going to make our own rectangles to fuck around with, and that's about it, I think. All right, everyone, have a good night. Goodbye.